All right, this is concept development for Module 6, Lesson 13. You hopefully have a note card, a ruler, and some scissors. All right, so what we're going to do to start off with. Now, this is the rectangle that we're actually working with, but it is copied on two sides here, so you can't actually cut this out. So what you can do, now I tried it two different ways to check it out. Now, one way was to use the paper in behind the Fluency, and I placed this under here. And then I simply just traced it, and then I used my ruler to make the edges straight. That is one way to do it. Or you could measure with a ruler, and I measured out 2 by 1, and let's see, it goes by almost like 16, so it's just after. Here's a quarter, a half, and just past 3/4 on that one. So what I'm going to do now is I drew it on my note card, and now I'm going to cut it out. So now it should fit right inside here. I think this side could be trimmed down just a bit. It takes you a minute to catch up with me. Just stop the video. And then what we're going to do is just draw the boxes inside. So it looks like the boxes are here, 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 here. And then, so I'm going to use my straight edge. I'm going to use my ruler to draw this out. Draw straight lines. It's not very straight. And then we're going to divide this up. And it looks like the middle is going to hit right here. So now we end up with this right here. So because we couldn't cut it out, because it's two-sided, we need to improvise. So you can use a piece of paper, which I used for this guy. I just used the extra page that was on the back of the Fluency for Module 6, Lesson 13. Or I just used a note card, measured it, and cut it out. So I'll give you a second to get that taken care of, and then join me when you're ready. All right, so what I want you to do next, we're going to do this twice. So here, I want you to draw a diagonal line. Then on your rectangle that you cut out, I want you to draw a diagonal line. Now, this is the part that comes with scissors. Since we can't cut this one out, I still wanted you to be able to see it here in case this isn't perfect. So we're going to cut it on a diagonal. And then you can just put one of the halves off to the side. So what do you know about a triangle? What do you know about this type of triangle? Well, one angle is a right angle and measures 90 degrees. Isn't that correct? So this angle is a right angle and measures 90 degrees. One side is 2 units long. Look at this is 2 units long. 1, 2. And this side is 5 units long. This one is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, right? All right, the angles aren't this angle and this angle are going to be acute angles. I mean, what does acute mean again? Less than 90 degrees. So acute and acute. So now place your, I'm going to switch. All right. All right, so what I want you to do is now just take your triangle right here. And I want you to, we're going to draw it out. We're going to draw out a line. Hold on 1 second. We're going to draw out a line. So I think we're going to need to draw a line with our ruler across the bottom here. Let's make a straight line across the bottom. Okay, so I drew a line that we're going to be working from. So what I want you to do is place your triangle on the line. And first of all, I want you to, I want it placed so that the 5 units is along the bottom here. And then the 2 units are along the top here. That's how I want you to line it up. Then I want you to label right here. I want you to label it R. I want you to label this angle R. I want you to label this angle T. And I want you to label this angle S. So go ahead and do that. So this is triangle TRS, SRT, RTS. So in order to name this triangle, you would name it by the letters, by the angles. So now what I want you to do is I want you to draw a line from T to S. So, or S to T, however you did it. So this is ST. This is line ST. Now we're going to slide. So this is line ST right here. Now we're going to slide our triangle off just a bit. Just move it just a bit. Now you are going to trace a second line across here. So it's a second ST line. So they're exactly the same. Now, what do you notice about the 2 line segments you have drawn? What do you notice about these 2 line segments? Well, we trace the same segment twice, so they're the same length. They are parallel because angle S is the same and comes out of the same line. So now let's try it in this direction. So we might want to move this down, draw another line so that we make sure we're drawing straight lines. Let's draw another line down here. And then we're going to place our triangle in this direction vertically. And then we're going to draw that same angle, T and S. We're going to draw it. And then we're going to move it off to the side. And we're going to draw it. I'm going to draw it again. Now, what do you notice about these two lines? Well, they're just like this. They're parallel, and we use the same angle and traveled. So we know that the lines are going to be parallel. Now, if you want to try to draw out a few more of these squares or rectangles and then cut them out, cut them in half, cut them diagonally, and figure out what would their parallel lines look like. That would be a fun activity. All right, now you don't want to lose these triangles if you did cut them out, because we're going to use them again this week. So moving on, let's now go to this side, to the next side of our concept development, our problem set packet. And I want you to look at line segment AB and CD. Using the grid lines, I want you to visualize a right triangle that has AB. Did you get it? Do you see it? So the triangle is here, correct? So it has a height of 2 and it's 3 units long. Do you see that it is 3 units long? And it has a height of 2. So a height of 2 units and a base of 3 units. The right angle would be at the bottom and across from line segment AB. So the right angle is here, and it's across from line segment AB. Now, there's also, if you're visualizing, did you notice that there's actually a triangle up here as well? And measures exactly. So there's a right angle on this side and a right angle on this side. So the right angles are across from one another. So this is almost like a perfect rectangle that's been cut diagonally. So when you have two triangles, when you have a rectangle, if you cut it diagonally, you're going to end up with 2 identical triangles. So now we're going to shade in the triangle. So if you have a colored pencil close by, grab it and we're going to shade it in. The triangle has a height of 2 units and a base of 3 units. So we're going to mark the angle with the right angle symbol, which we already did. If you didn't do it now. And shade the triangle on your paper. Now, look at line segment CD. Shade a right triangle that has CD as its longest side. So what is that going to look like? Well, it's going to look like this. And it has a height of 2. It had height of 2 units and then a length of 3 units. We have another right triangle right here. And if you can visualize, there's one on the opposite side as well. Now, look at line segment CD and shade in a right triangle that is CD, where CD is longest. So now if you want to choose a different color, go ahead and do that. That's perfectly fine. So what do you notice about the 2 triangles that were used to construct each segment? What do you notice? Well, hopefully you're saying they're the exact same triangle. For CD, the triangle just moved over to the right, and the triangles have the same side lengths, and the angles look like they're the same size too. So this is the same as when we slid our triangles. I'm going to pull out my triangle really quick. That's the same as when we slid our triangles. Along the straight edge. Now the triangle is sliding along grid lines. See, here are grid lines. We can say then that segment AB, and this is how you, AB, segment AB is parallel to CD. And that's how you, this is how you mark it. AB, line segment AB is parallel to line segment CD. Well, what is something, how could you prove it? How could you tell someone, well, this is true because? Well, they are parallel because they intersect the grid line at the same angle. So let's go over here to EF and GH. If EF was drawn first, how was the triangle moved before GH was constructed? So now I want you to do EF and then figure out how did you move? How was the triangle moved? So if you're here, how was the triangle moved? So construct, what I want you to do is I want you to construct your triangle for EF and shade it in a color, and then do the same thing for GH and shade it in and come back and check. So is this what you came up with? Do you have a triangle now that is 1 unit in height and 2 units in length? So my question before you drew these was, how was the triangle moved before GH was constructed? So how did this line move? How did it move? How could you describe that as moving? So the triangle moved to the right and then down, correct? So I can see that the triangle moved 1 grid square down and 1 grid square to the right. So that means the segments endpoints moved the same way. So now, what about K and L and I and J? So we're going to look at I and J. So now I want you to shade in the right triangles. I want you to create 2 triangles with I and J and K and L. Come back. You can shade those in too if you want, and it doesn't matter how. You can even shade it in with pencil. That's perfectly fine. All right. So were you able to create these 2 triangles? Excellent. Wait, before we move on, EF is parallel to GH. Make sure to write that down, annotate that. Then over here, we have, are these segments parallel? Are these 2 segments, the length part, the 1, 2, 3 and the 1, 2, are they parallel? No. The triangle IJ is taller for sure, and KL has a height of 2, and IJ has a height of 3. So if you visualize, and I took my ruler and I extended the top line. I can see that if we extend each line segment, they intersect. So as I extend these segments, are they parallel? No, because they intersect, so they can't be parallel. Now, let's consider something else about these segments. Imagine that we slid the longer segment over 1 unit to the right. So 1 unit to the right. Would this segments line up perfectly? So imagine we slid this over. Would they line up perfectly? Well, can you see the little one inside the big one? They are at different angles, so they won't line up. The acute angles in the triangles are different sizes, so they don't have the same steepness, which means they're not going to line up. One segment is over 1 and up 2, and the other one is over 1 up 3. That makes the angles on the triangles different sizes. So now look, let's why are we doing this? Okay. Why is this so freaking important? Oh, this shouldn't be in here. Shoot. One, two. Oh.